Thank you so much for joining us today. So we are done with vector algebra. The next video we are going to talk about differential equation. I love differential equations. So let's go through these 20 sets questions, and then so that it will prepare you towards your upcoming quiz, right? So what we are going to do is I'll try and give you the tips, the tricks. So please stay here so that we can go through the whole of 20 questions, and then you'll be able to understand when I see the question how I'm going to approach it. So stay here with me. All right, so let's look at the first question here. We want to find alpha such that we have vector A and B, and we are saying that this vector A and B are perpendicular. So you see that this question is kind of open. So the question is, everything that we've learned under vectors, which one do we need to use? So we need to remember that here we need to use the dot product, because we said for two vectors to be perpendicular, then it means that when we dot them, we should be able to get what? 0. So it means that for me to solve this here, what I'm going to do is when I dot A to B, I should be able to get 0 because they are perpendicular to each other, right? So that's the first thing that you need to remember, and then you are done. So I'll be showing you the tips, the tricks that you need to also learn. So let's just go through the process. So my A is alpha I minus 2j plus 2k dot alpha I plus alpha j minus 4k is equal to 0. So I hope you've not forgotten. We said whenever we are dealing with dot product, we just multiply direction by direction, right? And then we are done. So I'll multiply I to I, j to j, and k to k. So alpha times alpha I is going to give us alpha squared minus 2 alpha, then minus 8 is equal to 0. So what did I do? I multiply this by this, and then multiply this by this, also multiply this one by this, and then this is what I'm going to get. So this is kind of quadratic. So I just need to, if you are using calculator, you can just punch it on the calculator and then you pick one of the options. Very simple, right? So basically that's what you are going to do. So let's assume that I'm not using calculator. So let me just do the factorization and then we go. So two numbers multiply, I'll get 8, and subtract, I'll get okay, I can use 2 and 4. So alpha squared minus 4 alpha plus 2 alpha minus 8 is equal to 0. So from here I'll factor alpha out here, and then I'll factor 2 out here. So I'm going to have something like alpha out, alpha minus 4, so from the red side, and then from the blue side, when I factor 2 out, I'm going to have alpha minus 4 is equal to 0. So this is going to give us alpha minus 4, then alpha plus 2 is equal to 0. So I pick alpha minus 4 is equal to 0, alpha is equal to 4. Then I pick alpha plus 2 is equal to 0, and alpha is equal to minus 2. So alpha is equal to 4 and alpha is equal to minus 2 is the solution. So 4 and minus 2. 4 and minus 2. Okay, so we have it here, B. So you see that whatever we want to do is like we are trying to do it very fast. So if we're able to understand the question, you'll be able to go very fast, right? So now let's look at question 2. So question 2, we are asked to find the angle, the interior angle at the point A, right? So what do we need to do? First, you need to ask yourself, what formula am I going to use, right? So everything that you've learned so far, what are you going to use here? So here we need to think of, remember we wrote some formula like this. A dot B is equal to the magnitude of A, magnitude of B, cos theta. Good. So this is what you are going to use. But here there is something small that is kind of tricky here that I'm going to show you. So here, since we have 3 vectors, it means that we need to combine these 3 vectors to get 2 of them. But since it's at the point A, then it means that what we are going to do is we are going to look for vector AB and then vector AC, because the point is at A. So A goes with B, A goes with C, right? So let me just shift this one here. Now what is vector AB? Vector AB is small b minus a, and vector AC is small c minus a. So what is small b? Small b, we can get it from this. So let's write the position vector for that. That one will be I plus 2j minus 4k, right? So this is going to give us this. What is a small a? Small a, we can get it from here. Let's write it in the position form, 3I minus j plus 4k. And then last one is the c. We can get it from this. We are going to have negative 3I plus 2j plus k, right? Let's form them and see what we are going to get. So AB is equal to I plus 2j minus 4k, minus a is 3I minus j plus 4k, right? So let's try and simplify that. I plus 2j minus 4k minus 3I plus j minus 4k. So let's simplify this, and we are going to have minus 2I plus 3j minus 8k. So that is AB. Let's look for vector AC. So vector AC is equal to C minus A, right? So what we are going to do is we pick the C, which is minus 3I plus 2j plus k, minus A is I plus 2j minus 4k. So this is going to give us minus 3I plus 2j plus k minus I minus 2j plus 4k. Simplify that and we are getting minus 4I. So 2j minus 2j will be 0, and this will going to give us I think plus 5k. So this is what we are going to get. So what we need to do now is we need to use the formula. So it means that we are going to, since we want to get the angle, we are going to use the dot product. So AB dot AC is equal to the magnitude of AB dot the magnitude of AC dot the cos of theta. So now we are looking for cos theta, right? That is the most important thing that we are looking for. So now let's look for magnitude of AB. Magnitude of AB is equal to this is AB, so let's find the magnitude. Negative 2 squared plus 3 squared minus 8 squared plus minus 8 squared. So let's simplify that. What are we going to get? This is going to give us 4 plus 9 plus 64, and this is going to give us, I think, 77. Is that right? Yes, of course. So now another one that we need to look for is magnitude of AC. So what is C? C is here. So we are going to have root of minus 4 squared plus 5 squared, and this is going to give us 16 plus 25. So this is going to give us square root of okay, let me see something here. So I think I made a big mistake somewhere. This is supposed to be A. So A is 3I minus j plus 4k. So this is going to give us 3I plus j minus 4k. Okay, good. So this is going to give us minus 6I plus 3j. Okay. Then minus 3k. So we need to have something like this. Okay, so now let's find the magnitude again. So the magnitude now is going to give us minus 6 squared plus 3 squared plus minus 3 squared. So this is going to give us 36 plus 9 plus 9, and this is going to give us 54. Good. So now this is this one is root 77, this is 54. Let's look for AB dot AC, because that's what we need so that we can calculate for the angle. So now this is equal to, this is minus 2I plus 3J minus 8K dot, then C is minus 6 plus 3J minus 3K, right? So I just multiply this by that, and this is going to give us 12 plus 9 minus, no, it's supposed to be plus 24, right? So this is going to give us, what are we going to get? This one should be 45, I think. Yes. So this and this will give us 33, 45. Okay, good. So we have all the ingredients now, so we can just put them together and then we are done. So let me just move this guy somewhere here now. Let me see. Okay, let me just arrange my board so that I can have some space and put it there. So let me move this guy somewhere here. Good. And then let's continue from here. So it means that I'm going to have 45 is equal to square root of 77 dot square root of 54 cos theta. So what am I going to get? This is the same as 45. Since this is square root, I can just combine it and multiply 77 to 54, and I'm going to have 415 cos theta. So now cos theta will be equal to 45 divided by square root of 4158. And then if we are finding for theta, theta should be equal to cos inverse of 45 divided by square root of 4158. And this is equal to something like 45.5, which is the same as 46 approximately. Now you see this one, because I'm teaching you, I'm just going through the whole solution. But what if you are doing it? Some of them you can just use calculator and just punch it and then you are done. So this one like this, you can just finding the magnitude, you can use the calculator, you punch them, you write the answer down. This one to the same thing, you write the answer down, followed by when you want to do the product, you can some of them you can just use your eye and just put them down. And this one like this, you can just put it on a calculator and then you punch it once and you get the results there. So this is supposed to be 46. So we have the 46 here. So that's what we are going to get for this question 2. Good. Let's look at 3. Okay, so we are using this this preamble here to answer question 3 and 2. Now we see that now here we want to find the interior angle at the point B. So here B is the one that we are going to use to distribute for A and what? C. So this is going to give us something like, we need to look for BA and then we need to look for BC. So that's one thing that we need to know. You see, whenever we are solving, we try to use the first point, A, to distribute. But since we want to find the angle at B, then this is what we just need to do, right? So this is what you are going to get. So now this is going to give us, we need small b minus A, right? And then this is also going to give us C minus B. So this is what you are going to get. Okay, I think let me see. This one should be AB rather. AB. So this one is going to be A minus B. The idea is that we have, let's assume that if the vector is like A, B, and C, this one will move from A to B and B will move to C. So it's going to be A to B and then B to C. So this is how it's supposed to be. So instead of this one, the point was at A. So we move from A to B and A to C. But since the B is at the middle, we need to move from this side to this, and then we move from B to C. So that's what we are going to do. So pay attention to the vector properties. So we know A from here. So A is 3i minus j plus 4k, right? Then minus, what is B? B is I plus 2j minus 4k. Is that right? Yes, of course. So now let's try and simplify that, and then we just go through the same process. So it's the same process that we are going through. So this is going to give us 2i plus j, and then the other one, I think it will go to 0, right? Or it's not going to go to 0. Okay, this and this will be positive, so it's going to give us plus 8k. Let me look at this one. This minus this one's supposed to be minus 3j. So 2 minus 3 and 8. Good. Let's look for this. C is minus 3i plus 2j plus k, right? Good. And then B is I plus 2j minus 4k. So this is going to give us minus 4i, and then indeed the middle one will go to 0, and then the last one will be plus 5k. So this is what we are going to get. Let's go through quick. Let's find for the magnitude of AB. Magnitude of AB will be 2 squared plus minus 3 squared plus 8 squared. This is going to give us 4 plus 9 plus 64, and this is going to give us same thing, which is 77. And then we need to look for BC. This is going to give us minus 4 squared plus 5 squared. 5 squared. This is 5. So somebody was complaining about my handwriting. I need to write well. So this one will be 16 plus 25, and this is going to give us root of 41. Let's find the dot BC. This is going to give us, so let's multiply them together. So this is going to be 2i minus 3j plus 8k dot minus 4i plus 5k. So dot I to I, this is going to give us minus 8. This will be plus 0. And then this one will be 40. So we are going to have 32. So good. So now let's look at what we are going to get. So we know that here theta will be equal to cos inverse of AB dot BC divided by the magnitude of AB dot magnitude of BC. Good. So this is what you are going to get. Now the dot was giving us 32. So this is going to give us 32 divided by, I need to bring the cos inverse. This is 32 divided by the magnitude of AB was root of 77 dot root of 41. So when I multiply that, I'm going to have cos inverse of 32 divided by, when I multiply that one, I'm going to have 3157. Find cos inverse of this, and we are going to have something like 55.3, which is approximately 55. 2 from that side. Now let's look at this. This question, it's too long. I love it, but when you understand it, you'll be able to do it. So if I make sure that this one here is, let's say, u, vin, and t, you will see that I'm going to have lambda like u dot vin cross, let's say, t. And we know that this is the scalar triple product, right? Scalar triple product. So that's what you need to remember from here. So what do we need to do? It means that this one, what we are going to do is, for us to solve this, we need to do the cross first so that we get a vector and then we use to dot the u. Basically, that's what you are going to do. So with this one, what I'm going to do is a plus b dot b plus c cross. Pay attention here because it's kind of very tricky. Try and understand it so that you can apply it to any of them that you are going to do. Now, this one, for me to solve, I need to look at the options. So some questions, you need to pay attention to the options before you start solving. So I'm looking at the options before now I start working towards it. Now let's go. I'll pick this one first because this is the cross. So now let's move. I'll pick that one. So b plus c cross c plus a. So this is equal to, so I just want to cross these two vectors together, right? So this one is kind of like we need to use the idea of the distributive property, right? So I'm come to actually do distributive property. So I pick the b, then with the c, I pick the b with the a, then c to c, and then a to a. So that's what I'm going to get from here. So this one is going to be b cross c plus b cross a plus c cross c plus c cross a. So what did I do? B cross c, right, plus b cross a, right? Then I move to c. Now I'm here. C cross c. Then I have plus here, so plus c cross a. So that's what I'm getting here. Then let's use the properties. Now I know that when I cross the same vector, I get 0, right? When I cross A to A or the same vector, you can check it. You can pick any random vector and cross itself. You are going to get 0. So this is going to give us 0, right? So if this is going to give us 0, then it means that basically some of the terms is going to just go away just like that, right? Now, what I want to do is I want to make sure that my terms too are also in order, like alphabetically order. So this one is already in alphabetically order, B, C, right? But this one here, the one with the green, is not like in alphabetically order. So I want to switch it. So if I want to switch this, remember the property that we learned. This is the same as minus A cross B because we are dealing with cross. So the order is important. So this is what I'm going to get from here. Then if I want to interchange A and C, this one too is going to give us minus A cross C. So it means that the one in the bracket here, this is going to give us B cross C. Then this is this. So it's going to give us minus A cross B. And then this is 0, right? So it's go away. And this is equal to this. So this is going to give us minus A cross C. So this is what you have gotten from this. Now we need to dot this with that. So let's do that. Now I'm going to pick the A plus B dot the whole of this. So let's see what we can get. So A cross C, no, B cross C minus A cross B minus A cross C. So let's try and simplify this. Now this one, to see what I'm going to do, I'll just multiply this using the dot product, right? So this is just a vector. So I'll use this one to multiply this one to multiply this one to multiply this. So this is going to give us A plus B dot A cross C minus, so minus is here because now I take this one, then use to multiply this. So this is going to give us A plus B dot A cross B, then minus A plus B dot A cross C. So what did I do? Just pick this one to multiply this, then minus, then I pick this one to multiply this, then I pick this one to dot this one. So that's what I'm getting. Now, what we just need to do is, now here we need to do something like, we need to also expand this. We need to multiply this. So what are we going to get from here? Look at this one. I'm just picking the one that I've underlined. You see that this one, I can write it as, I'm writing it here, A dot B cross C, right? I just multiply the A to the whole of this. Then plus, so I have the plus. Then I multiply the B to this. So I'm going to have B dot B cross C. So I'm going to do the same thing for this one too. So minus, let me put this one in parentheses. This is going to be A dot A cross B plus B A cross B. I finish this one. Now the next thing that I need to do is the same thing here, minus A cross, no, A dot, so there is dot A cross C plus B A cross C. So what did I do? It's just simple. Just pick first term, multiply, plus pick the second term, multiply, in that order. Now let's use the property. Now we know that when I want to use the scalar triple product, and I have something like A dot A C, something like this is equal to 0, because we have one vector repeating itself. So as soon as I see one vector repeating itself, it's going to be 0, because we know that if I cross two vectors, I'm going to get 0. So because of this, this will be 0. So it means that, let's go through, anytime we see the same vector repeating itself, that one will just go to 0. So we see that from this one, A is repeating itself, so this one will be 0, right? This one too is also repeating itself, this one too will be 0. This one too is also repeating itself, this one will go to 0. I think this one too is also repeating itself, so this one too will go to 0. So this one is different, A, B, C. This one too is A, B, C. So this is the terms that's going to be left for us to, try to manipulate. So now let's see what is left. So everything is gone, and it is left with A dot B cross C. And then, so this one's gone, gone, gone. Then we have minus here, so minus this. So minus B dot A cross C. So that is what is left. Now, what we want to do now is, now we want to make sure that this one is also of this form. You see that this one is like alphabetically, it's in order. So we want to switch it so that we get it in this form. So now let's switch this guy here. I'm picking B dot A cross C. Now we know that since this is scalar triple, what I can do is, I can switch the B in between, right? I can just switch the B in between. But you see, because I want to get something like this, because I want to get something like this, I want to move the B in and then move the A out, right? But if I want to do that, then something is about to happen. So see what is coming to happen here. First, remember, if I have A cross C and I want to interchange this one, this is the same as minus C cross A, right? This is true. Do you agree with this? Yes, this is true, right? So this is what you are going to get from here. So if this is true, then it means that this is going to give us B dot, so it's going to be minus B C cross A, right? So this is kind of the same as minus B dot C cross A. Then now I can move the B inside and bring the A outside, right? So this is now going to give us minus A, then minus A dot B cross C. So this is what I'm going to get. So if I want to, the reason why I swap it is, anytime I want to move something inside, the one that can come out is the last one. So you see that this one here, if I want to move the B inside, you see that I cannot switch the A and B from here, but here I can move the B inside and the C can come outside. So what I need to do is I need to make sure that the A is at the latter part here, so that when B is moving, the A comes out. So that's the reason why I did this. So for me to make sure that the A comes out, I need to switch this A cross C by writing it as A C cross A minus, so that now when I bring the minus out and I want to send the B inside, then the A comes outside. So basically that's what we were just doing. So we are almost done. We are done. So now we are having A dot B cross C minus A, because this is minus and we are getting minus here again. So this will be A B cross C that. Now I have this guy here, I have this guy here, I can factor it out, right? So look at what is going to happen. When I factor it out, or let me say, yes, or let me say, let me just multiply it through first. So A dot B cross C, this is going to be minus, minus is going to be plus. So plus A, then dot B cross C. When I do this, you see that now this one will be the same as this. Come in, let me just move this guy here. So this is the same as this one here. When I factor this guy and this guy out, it will be left with something like A plus A dot B cross C. Do you agree? I factor this one out, I factor this one out. So when I cancel this and cancel this, you see that it will be left with A plus B, and then the dot will be here. So this is what I'm going to get. So finally, I'm going to have something like 2A dot B cross C. So this is what I'm going to do. So this is kind of question that if you don't know how to solve it, like, you will just be there, you will get it wrong. But since we've gone through the process and you know how to do the expansions, if the question is different, you should be able to go through the same idea. So I would like you to, write this question again, go through the process by yourself to find out if you can do it. So what was the answer? 2AB cross C. So the answer is B. So write the question again, try and solve it again, and see what you are going to get. Now let me move a little bit fast. Let's look at this one. We want to find the magnitude of R1. So this is kind of very simple. This is R. So 3 squared minus 2 plus minus 2 squared plus 1 squared. So this is going to give us 9 plus 4 plus 1 plus 1. And this is going to give us root of 14. So this is very simple. Let's move fast. That's why we want to find the magnitude of R1 minus R2 minus R3. So what is R1? R1 is 3I minus 2j plus k, minus R2 is 2I minus 4j plus 3k minus R3 is minus I plus 2j plus 2k. Is that right? Good. So we just need to do this and then we are done. So I just do it straight. So minus 3 minus 2 is 1. And then this one will be plus. So we are going to have something like 2i. Good. I'm just doing straight so that then this minus here will be, okay, let me just expand so that we will be on the safer side. So 3i minus 2j plus k multiplied through by minus, okay, and multiply through by minus. Good. So let's go I here, I here, I here. This is going to give us 2i minus 2. This one will be 2. This one will be 0. Is that right? Yes. So that one will go to 0. And then let's look at the k. This one will be minus 2. So this one will be minus 4k. So what we just need to do is we need to find the magnitude and then we are done. So the vector questions, it's kind of like if you are solving them, if you don't know some shortcuts and you are solving them, you will see that you are going to waste a lot of time. You won't even finish. They will say stop work. So try more examples so that you will know how to go through the process, and then you'll be okay. So what is root of 20? I can write this one as 20 is the same as 4 times 5. So this is the same as 2 root 5. Is it that I didn't do my multiplication well, or I had it? Okay, let me look at my point. 3, 2, 1, 2 minus 4 minus 3. Okay, so I made a mistake here. This supposed to be minus, yes. This is supposed to be minus, and then minus 2, 2. Okay, so if this is minus, then this one will tend to be positive. So this is going to be, this will be 4, and this one will be 2. Okay, so this one will be 2, positive 2. Okay, so this one will be 2, and this one will be 4. This one will be 8. Okay, then square root of 8 is this is the same as 2 root 2, but it's the same as square root of 8. So we have this one here. Good. Okay, so this one is the triple scalar product. So R2 dot R1 cross R3. So we know what to do. So R2 is 2, 4, 3. So 2 minus 4 minus 3, right? 2. Okay. Then R1 is 3 minus 2, 1. 3 minus 2, 1. Okay. Then this one is minus 1, 2, 2. Minus 1, 2, 2. Okay, so let's just do the dot and then we are done. Okay, so let's just go through the process. What do we do? So I maintain, don't forget the cofactors, plus, minus, plus, minus, plus, minus, plus, minus, plus. So this is going to give us, cancel this one out. We'll be left with minus 2, 1, 2, 2, then minus 4. So this is minus, and I have minus 4 here. So cancel this one out. It will be left with 3, 1, minus 1, 2. And then the last one is the minus 3. So minus 3. Cancel minus 3 out. Then you have 3 minus 2, minus 1 and 2. So what are we going to get here? 2 times, this is the 2 by 2. So this is minus 4 minus 2 plus 4. This is 6 plus 1 minus 3. And this is going to give us 6 minus 2. Good. Good. So 2 minus 6 plus 4 times 7 minus 3 times 4. This is going to give us minus 12 plus 7 times 4 is 28. I think so. Is that right? Yes. Then minus 12 again. So this is going to be minus 24 plus 28. And this is 4. Do we have 4 there? Okay. Since we have 4 here, then that's good. So basically, when you are doing it, you need to remember which approach are you going to also use, and then you should be very quick with your process. So okay, this one we want to find the magnitude of this. 2R1 minus 3R2 minus 5R3. Okay, let me leave this one for you to do it. So you are using the same information here from 5. So use the same information here and choose your final results and leave it in the comment section for me to see, right? This is kind of very simple. Let's look at question 9. Okay, question 9, eliminate the arbitrarily constant a and b from the equation, right? So we have a and b and we want to eliminate it. So for us to do the eliminating, we need to look at the solution here. So we can see that the solution here is actually talking about partial what? Derivative. So for me to start, then I need to simplify this one first. X plus a, y plus b. this is the same as xy plus xb plus ay plus ab. How did I do that? I multiply this one by this, multiply this one by this, then a times y, then a times b. So that's what I did. So let me name this one z. So what I want to do is I want to look at the options here. So you see that all the options is differentiating z with respect to x. Some of them are once, some of them are twice. So I want to do that. But I need to do it in such a way that I eliminate the constant. So first, let me take first partial with respect to x and c. We are differentiating this with respect to x. When I differentiate this with respect to x, I'm going to have y, because when I differentiate x, I'll get 1. I'm treating this one as a constant, so I get y. Plus, when I differentiate this, I'm going to have b, because when I differentiate x, I get 1. There is no x here, so these are constant. When I differentiate, it goes to 0. I've differentiated it with respect to x, but still I have the constant in. So how am I going to do? I need to differentiate again till I eliminate the constant out, which is b. We don't want the b inside. So let me differentiate again. So I differentiate this divided by this one. When I differentiate y with respect to x, it's a constant, so it will be 0. When I differentiate b, also constant, so this is going to give us 0. So stopping here, we see that there is no b, so we stop here. So that's one option. Now let's go with the idea of getting the y. So now we see that the option, this one is out, because this one differentiated the x only one. So now the option left is this, this, and that, because all of them are having the second derivative. But let's go for second derivative for let's differentiate with respect to y and see what is also going to happen. So with respect to y, differentiate this with respect to y, this will be left with x, because differentiating y is 1 with 1. So plus, there is no y here, this one will be 0. There is y here, so this one will be left with a. There is no y here, so this will be 0. Still, I have a constant inside. I have the a that I want to eliminate inside. So I need to differentiate again. So I differentiate this one again, and then I have this. I differentiate x, there is no y, there is no y, so everything here goes to 0. So basically, for us to eliminate these two functions, then we need to do this. And what can we do? Looking at the options, we just need to add. So z squared with respect to x squared plus with respect to y squared is equal to 0. So when I add this to this, it's going to be 0 plus 0, which is equal to 0. So it means that the right option here is A. So that's how we eliminate some arbitrary constants from the equation. Now let's look at question 10. Okay, so this one too is the triple scalar product, right? So let's just do it. So I have 2i plus 3k dot I plus j plus k cross 3i minus j. So let's do it. So this one has no j, so I'm going to have 203. And this one is going to be the second one, so 111. And then this one has no k, so this is going to give us 3 minus 1 0. So we just need to do this one and then we're done. So 1 minus plus plus minus plus minus plus minus plus. Just have this in mind anytime doing this. So this is going to give us 2. When you maintain the 2, when you cancel 2, you're going to have 1 1 minus 1 0 minus 0. This one is 0. We don't need to write, but let's write 1 1 3 0 and then plus 3 1 1 3 minus 1. I hope you saw how we did it from there. So this is going to give us 2 times 0 plus 1. Then this one will be minus 0. Everything will be 0 plus 3 times minus 1 minus 3. So this is 2 times 1 plus 3 times minus 4. This is 2 minus 12, and this is going to give us minus 10. Oops, we don't have minus 10. All right, let's look at question 11. Okay, good. Question 11 is find a constant A such that these three vectors are coplanar. So we said whenever we are talking about coplanar vectors, they are parallel to each other. So remember we said triple scalar products are, they are parallel to each other. So it means that since these vectors are, let me say, coplanar to each other, if I assume that A is equal to the first vector, B is equal to the second vector, which is I plus 2j minus 3k. If I assume that C is equal to 3I plus 4j plus ak, then since they are coplanar, right, A dot B cross C should be 0. So this is the idea that I'm going to use to solve this. Good. So let's go through the triple scalar product or scalar triple product. So this one will be 2 minus 1, 1. So I'm picking the first A, and then followed by B. So I pick the B here. I'm going to have 1, 2 minus 3, and the C is 3, 4, A, right? Good. And this should be equal to 0. So let's try and solve for A. So I maintain 2, cancel, and I have 2 minus 3, 4A, minus 1, cancel out, have 1 minus 3, 3A, plus 1, cancel out, you have 1, 2, 3, 4. Oh, nice. 1, 2, 3, 4. This is 2. This is going to give us 2A plus 12 plus. So this is going to give us plus. Then we are going to have A plus 9 plus 1. This is going to give us 4 minus 6 is equal to 0. So this is going to give us 4A plus 24 plus, this is A and this is 9. So this is going to give us A plus 9, then minus 2 is equal to 0. So let's try and simplify. This is 5A. So this and this will be 5A. Subtract minus 2 from this guy is going to give us 7. 7 plus this one is going to give us 31. So plus 31 is equal to 0. And 5A is equal to minus 31. So A should be equal to minus 31 divided by 5. Do we have it? Good. We have minus 31 over 5 right there. And let's look at this one. I think we have some interesting questions that are coming up. We have forces, this, that, and that. And then we want to find the magnitude of what? The resultant. So what we just need to do is let's assume that the resultant force is equal to big F, right? So the resultant force is basically equal to F1 plus F2 plus F3, adding all the forces together. So let's add them and see what we are going to get. This is 2I plus 3J minus K minus 5I plus J plus 2K plus 6I minus K. This is going to give us something like this. Now add this to this, all the I and then all the J's. So this is going to give us 3I, right? And then the J's is going to give us 4J. And then the K's is going to give us, the K's will just go to 0. So I'm going to have this. So now remember the question is asking us to find the magnitude. So what is the magnitude of the resultant force? This is square root of 3 squared plus 4 squared. This is 9 plus 16. And this is square root of 25. And this is a big 5. So we are getting a big 5. So some of the questions are very simple for you to just go through very quick, and then you are done. Question 13. I love it. So they've given us information, P and Q, And then we want to use the information to answer question 13 and 14. Find the equation for the plane passing through Q and perpendicular to the line PQ. So remember, anytime we are saying that it's perpendicular, this here, remember, since this is perpendicular to this line, then this is the normal vector. That's what you need to remember. But what's the first thing that we need to remember? We need to remember the formula for finding equation of the plane. So equation of the plane, given this, we are going to use this one, ax minus x naught plus b y minus y naught plus c z minus z naught. So always remember the formulas that you are going to use to do a specific what question, looking at the question. So that's what you are going to use. Now remember, x naught, y naught, z naught can be any of this, right? Because I can write p as 3, 1, and 2, and q as 1 minus 2 and minus 4. So x naught can be 3, x naught can be 3 or 1. So this one, I can choose any of them and then I just put it inside this. So it means that when I do that, I'm going to have ax minus 3 plus b y minus 1 plus c z minus 2 is equal to 0. So the only problem here, or the only thing that I need to look for, is a, b, and c. Now a, b, and c are the coordinates of the normal vector. So a, b, and c, these are the coordinates or the coefficient of the normal vectors. So basically that's what we need to know. And we know that since this is perpendicular to the line PQ, and then PQ is the normal vector. So PQ, which is equal to small q minus small p, is equal to the normal vector that we are looking for. So let's do that. This is equal to small q is I minus 2j minus 4k minus small p is 3i minus plus j plus 2k. Expand that, what are we going to get? Minus 3i minus j minus 2k. Simplify that, minus 2i, is that right? Yes. Then minus 3j minus 6k. And we see that when we compare this to this one here, we can see that our a is equal to minus 2, our b is equal to minus 3, and our c is equal to minus 6. So the thing that we just need to do is, now we just need to replace this by what is here. So let's finish it up. We are going to have minus 2x minus 3 plus or minus 3 y minus 1 minus 6 z minus 2 is equal to 0. Looking at the options, I think we need to simplify before we can work through. So this is going to give us minus 2x plus 6 minus 3y plus 3 minus 6z plus 12 is equal to 0. So we have minus 2x minus 3y minus 6z. So 6 plus 3 is 9. 9 plus this guy is going to give us 21. So I'll multiply through by minus, or what I can do is I can move all this to the right side so that it comes positive. So 2x plus 3y plus 6. Let me see how the answer we're given. Okay. And then I'm going to have something like equal to minus 21. Do you have the results? Now, let me check the other point and see. Let me use the other point and see. So this is going to be minus 2, 3 minus the other point, which is q. I'm going to have 1 minus 3y minus, it's minus 2, so it will become plus 2, then minus 6, and then this one is minus 4, so I'll get z minus 4 is equal to 0. Let's expand this one and see. This one will be plus 2 here, minus 3y minus 6, minus z this. Then this one will be plus 24 is equal to 0. So what are we going to get from here? Minus 2x minus 3y minus 6z. Then this plus this is going to give us what is this one here? Okay, this one too is minus, so this one should be plus. So this is going to be minus. Good. So this plus this is going to be okay. So it means that this was going to give us minus 28 is equal to 0. So 2x plus 3y plus 6z is equal to minus 28. So this is going to give us the right answer. I'm choosing this one, but I don't know why this one is not giving us the answer. And the result is supposed to be D, but I don't know why I'm not getting the same answer. So it means that maybe we need to use the K, but I don't know how. Oh, okay. So I understand it now. I didn't check the question. The question said it passes through KO and perpendicular to PQ. So we cannot use the P. So my bad. So that is what we just need to do. So since the question passes through KO, then we need to use the X naught, Y naught, and Z naught should be the KO value here, right? And then now we find this one. So my bad for this one. So wait, let's just clean up this guy here. Good. Good. So we are using this one because it passes through Q. Good. All right. So we are getting D for that one. Let's look at question 14. What is the distance from the point this to the plane? So remember when we are talking about equation of the line, I think level 100 second semester, we talked about some formula perpendicular distance, right? Because this is coming from the plane. So from this point to the plane, so it's kind of like you're having something like this. So this is a perpendicular distance. So the distance, which we are going to call it a perpendicular distance, remember this is supposed to be ax plus by plus c divided by root of a plus b squared. But this one is in 3 dimensions, right? So it means that we need to modify it. So this is going to be ax plus by plus cz plus d divided by square root of a squared plus b squared plus c squared. So this is the formula that we need to use to solve the function. Now this is x, this is y, and this is z, right? So when I do that, I'm going to have absolute of, okay, let me just pick my a and b too. So remember what we had here. So we had 2x plus 3y plus 6z is equal to minus 28. Good, that's what we had. So when I move this guy to this side, I'm going to have 3y plus 6z plus 28 is equal to 0. So the coefficient here is a, b, c, and d. So a is equal to 2, b is equal to 3, c is equal to 6, and d is equal to 28. So let's just plug them in and then just find what we are looking for. So a is 2 times minus 1 because I have my x here. Then b is 3 times y plus c is 6 times z, then plus 28, then absolute of 2 squared plus 3 squared plus 6 squared square root. So let's try and simplify this and then we are done. So the top will be minus 2 plus 3 plus 6 plus 28 divided by 4 plus 9 plus 36. So the top is going to give us this, and this will be 1, 9 plus this should be 37. Yeah, it's supposed to be 37. Let me see. 2 plus this one will be 9. Yeah, 37. I think so. I didn't work it well. Oh no, this will be 1. So this one will be 7. 7 plus this one is supposed to be 35. If we're not using calculator, it's so bad. So this is going to give us square root of, add everything, and it should be 49. So this is 35 divided by 7. Yeah, and this should give us 5. Good. So this should be giving us 5, and then 5 is there. Oh, I love these questions. So now we want to solve this. We want to find r dot r prime. So remember, this is under we need to find the position vector first. So here we know that the position vector r is equal to xi plus yj, because we are in the 2 dimension, we have x and y. So this is going to give us r to be a theta minus sine theta I plus a 1 minus cos theta j. So let's try and then work out. Now first, let's find r prime. So remember, the function is in terms of what? Theta. So we are going to differentiate with respect to theta. Now maybe what I can do is I can simplify this one small so that we can see how we can do the differentiation. So this is going to be a theta minus a sine theta I plus a minus a cos theta j. So let's differentiate this with respect to theta. The first term, we are going to have just a, and then here a is constant. When I differentiate sine, I get cos. So I'm going to have minus a cos theta I plus, now when I differentiate this constant, I'll get 0. When I differentiate cos, I'll get minus sine. So this one will be 0 plus a sine theta. So maybe let's try and simplify that. Or yeah, let's try and simplify that. This is going to give us a minus a cos theta I plus a sine theta j. So our task is to multiply r to r prime. So this is r and this is r prime. So let's find the dot product for this. So r dot r prime will be a theta minus a sine theta or I plus a minus a cos theta or j dot a minus a cos theta or I plus a sine theta j. So dot product, I goes with I, so we multiply this by this. So we are going to have a theta minus a sine theta, then dot a minus a cos theta. Good. So we are done with the I direction. Let's go to the j direction. We are going to have plus a minus a cos theta times a sine theta. So now what we just need to do is let's try and simplify this and put some of the things inside so that we can, basically write it in other form. So let's look at how the solutions are before we even start solving it. Okay, so we can see that some of the solution is having y. So we can think of, okay, sometimes we can see something like we can put it in. Some of them too does not have y. So let's try and then find out what is going to happen. So first, let's simplify by doing the multiplication. So let's multiply this to this. This is going to give us x squared theta minus x squared theta cos theta. So multiply this one by this and this. Then I'll pick this one to multiply this and that. So minus a squared sine theta, then plus a squared sine theta cos theta. So I'm done with the first one. Let me come here. I'll multiply this by this. I'm going to have plus a squared sine theta. Then I multiply this one by this, and this will be minus a squared sine theta cos theta. Now looking at what I'm seeing, this guy will cancel this guy because this is a squared. This is a squared sine theta cos theta, a squared sine theta cos theta minus positive. So they go away. And then I think this one too will go away, right? Because they are the same. So it will be left with these two guys here. Now these two guys, I can factor a squared out and it will be left with, or I can even factor theta out. So when I factor this out, this one will be left with 1. And when I factor this one out, this one will be left with minus cos theta. So this is what I'm going to get at the end of the day. So you see that, okay, so this is basically not there. Is it there? No. Let me see. So what is 1 minus cos theta? So 1 minus cos theta is, okay, so I can see something here. 1 minus cos theta is kind of coming with y. So let me send one of the a inside. Okay, so because we don't have the solution there, but we should be able to figure it out. So I know that y is equal to a 1 minus cos theta. So this is one of the things that we need to pay attention to. So if y is equal to this, then what I can do is I can factor one of the a and multiply by this. So this is going to be a theta times a 1 minus cos theta, right? So when I do that, it means that this one here is going to give us y. So this is going to give us a theta y, and this is going to give us a. So this is going to give us a. So here we need to pay attention with the manipulations, right? So you saw the answer, you've got an answer, but the answer is not there. So you should be able to figure it out and then work it out again. Now let's look at this one too. We need to find r prime prime, which is the acceleration, right? So we know that, let me just pick the r prime. Let me just write r prime here and pick it there so that we can differentiate and get r prime prime. So now let's look for r prime prime. Now r prime prime is going to give us something like r prime prime is equal to this. So now let's differentiate this. This is a constant, so it will just go to 0. When I differentiate cos, I'll get negative sign. So this is going to give us a sine theta I, because negative sign will make this one positive. Then plus, when I differentiate sine, I'll get cos. So a cos theta j. So now what I need to do is I need to dot this with the r. Oh no, I'm not even dotting. I want to cross. So now we are looking for r cross r prime prime. So what are we going to get? We pick our I, j, and k. So let me open it big. So I, j, and k. So what is r here? R is, we have something like this. A theta, we have a theta minus a sine theta, right? And then we have, okay, I need to open this one again. And then we have, let me put my j here. Then we have a minus a cos theta. So that's what we have here. So I'm just picking the coefficient of r here and then this one here. So that's what I'm going to get. And then I don't have k, so k is 0. And when I come here, the coefficient of I is a sine theta, coefficient of j is a cos theta, and then I don't have k, so this one is equal to 0. So here, the best way to pick is we can pick this direction to do the calculation, so that this one will be 0, this one will be 0. So I don't need to pick this one, but you can just still go through ijk and just do it, but still it's going to be 0. So let's go through ijk and see. So when I cancel this one out and this one out, I'm going to have a minus cos theta, a cos theta, 0, 0, minus j, then cancel, cancel. I'm going to have a theta minus a sine theta, a sine theta, and then a sine theta, and then 0, 0. So that's what I'm going to have for the j. Then for the k is where now I can have all of them in. So I'm going to have a sine a theta minus a sine theta. Then I'm going to have a sine theta, then a cos theta, and then I'll be having this one too. Let me shift this one small so I can have some space here. So now this one is also a minus a cos theta with the bar last one there. So this multiply, when I multiply this one by this will be 0, this one too will be 0. So I'm going to have times 0 minus this one too will be 0, because this times this will be 0, this times this will be 0. So the actual work is at k. So now I need to multiply this by that. So I'm going to have something like a cos theta times a theta minus a sine theta, right? Minus, then I multiply this by this. So I'm going to have a sine theta times a minus a cos theta. Good. So that's what I'm going to get. This one will be 0 minus 0 plus k. Then now let's try and expand this one and see. So this time this is going to give us a squared theta cos theta minus a sine theta cos theta minus this times this is going to give us a squared sine theta, right? A squared sine theta. Now multiply this one by this is going to give us plus a sine theta cos theta. So fortunate for us, this will cancel this guy here. So it is going to be left with a squared sine theta, a squared theta cos theta minus a squared sine theta, right? And then this is going to give us something like a squared out, or I can even, yeah, s squared out theta cos theta minus sine theta. Let's see the options and see if we can do some manipulations here. So okay, basically we cannot do manipulations and the answer 2 is there, so we are done. So the answer is supposed to be D, because we have a squared theta cos theta minus sine theta, which is the same as what is here. So the answer should be D. Good. Now, last one is the question 17. We want to find the magnitude of r prime. We've done r prime already. So this is r prime. We want to find the magnitude. So pick the coefficient and square it. So we have square root of a minus a cos theta. So cos theta is going to give us cos theta squared. And then we are going to have something like a sine theta all squared also. So let's try and simplify this. This is going to give us the first term here is the same as a minus a cos theta, and then a minus a cos theta again. So this now is going to give us a squared sine squared theta for the last term here, right? So now let's try and expand the first term and see what we are going to get. So the first term is going to give us a squared minus a squared cos theta minus a squared cos theta again, and then plus a squared cos theta squared. Then the last term is sine squared theta. So what can we do here? Okay, let's look at the options. Okay, we look at the options and we do accordingly. So this is going to give us x squared minus, I can add this to this. So I'm going to have minus 2a squared cos theta squared plus this one, this two I can factor a squared out and I'll be left with cos squared theta plus sine squared theta. Now we know that this should be 1, right? So we are going to have 1 for that one. So this is going to give us square root of a squared minus 2a squared cos squared theta plus a squared times 1. And then I can factor a squared out. So I'm going to have square root of a squared out. This one will be 1 minus 2 cos squared theta plus 1. And this is going to give us a squared 2 minus 2 cos squared theta. Now we know that if I have a, b, this is the same as square root of a times square root of b. So I can do same here and have this one to be square root of a squared times square root of 2 minus 2 cos squared theta. So this is going to give us a times. This one I can factor 2 out and have 1 minus cos squared theta. So which term was giving us 1 minus cos squared theta? Let's go and look for it and see. Okay, I think I remember something. This is a property, right? Right. So if we are saying that sine squared theta plus cos squared theta is equal to 1, right? Is equal to 1. Then when I move cos to the right, I'm going to have sine squared theta to be equal to 1 minus cos squared theta. So it means that in place of this, I can put sine squared theta there. So I'm going to have a square root of 2 sine squared theta. Let me apply the same theory here. This is the same as a square root of 2 times square root of sine squared theta. And this is going to give us a sine theta, or let me say a square root of 2 sine squared theta. So let me see if we have something like that there. This one shouldn't be square. We have square root of 2 there. Yeah, square root of 2 is there. And then we have theta 2 out. Okay, let me check my r prime again. It's a minus that and that. Okay, let me just go through the whole process again and see if I did it right. Okay, so I think I've seen the mistake. This one is not supposed to be squared. Yes, this one should be the ordinary cos, because we know that when I combine this and this one should be 2a squared. There should not be squared here. The same thing here. So this one is not squared. This one is not squared. So this one is going to be something like this. And I think that's where the problem came. So this one too is not squared. So it means that if it is not squared, then this one is not true. What we did here is not true. Good. So 1 minus cos. Do we have 1 minus cos? Okay, good. So 1 minus cos is basically coming with y. So let's try and implement y inside the question there. Okay, then it's good to send the a back. So let's send the a back. This is going to give us square root of, when I send the a back, I'm going to have 2a squared because it was squared and we brought it out. So let's send it back so that we can have it and then put the y there. So this is the same as square root of 2a dot a1 minus cos theta. So we know that y is equal to a1 minus cos theta. So now this is going to give us square root of 2ay. So here it means that when you are doing simplification, you need to check the answers and see which one are you choosing. So yeah, the options are very important because the way they do the options, that's where you need to also pay attention to. Good. All right, let's look at question 18. Should I leave you with question 18 for you to do? I think so. So question 18, we just need to do just a linear combination and then you are done, right? So multiply 3 by a, multiply 2 by this one and just solve, and then you just choose the result from question 18. So let me do the 19 and 20 and we are done. So 19, we want to talk about unit tangent. So unit tangent, we need to remember the formula, right? So we are saying that one is just r prime divided by the magnitude of r prime. So the function is in terms of u, so we are differentiating it with respect to u. So let's look for r prime. So when I differentiate cos, I get minus sine ui, and when I differentiate sine, I get cos. So cos uj. Then what am I going to get? Find the magnitude of r prime, and we are going to have square root of minus sine u squared plus cos u squared. So this is going to give us sine squared u cos squared u, and this is going to give us square root of 1, and this is 1. So it means that the unit tangent is going to be equal to r prime is minus sine u I plus cos uj divided by 1, which is the same as minus sine ui plus cos uj. Let's see what we are getting. So we can see that indeed what is here is basically the r prime, right? So we can say that this is equal to r prime of u, since we don't have the final results there. So the answer there is going to be A, right? Because when we differentiated this, the magnitude was just 1. So when you divide it by 1, you get the same thing as r prime. So that's what we're going to get. Now we need to look at curvature, right? What's the formula for finding the curvature? This is magnitude, I think the unit tangent prime divided by r prime, good, or the velocity, the same thing. So we know we need tangent here. So let's find let's differentiate it again. So when I know that t is equal to t prime is equal to, no, t is equal to sine minus sine plus cos uj. So let's differentiate that. When I differentiate sine, I get cos. When I differentiate cos, I get minus sine. So let's find the magnitude. Basically, when you find the magnitude, this one to give us 1. So cos u squared plus minus sine u squared. This is square root of cos squared u plus sine squared u, and this is 1, and this is 1. Now, do we have r prime? Yes, we have r prime. And then do we have the magnitude of r prime? Yes, we have magnitude of r prime, which is 1. So we also know that the magnitude of r prime is 1. So it means that this is going to be magnitude of 1 divided by 1, and we are going to have magnitude of 1, it's 1. So this is going to give us 1. All right, so this is the end of the video. Basically, you see, this one we've captured almost everything that we've done. We didn't talk about finding the area of a triangle, finding the area of a parallelogram, and then do other things. So what you just need to do is, when you are going to write your quiz 2, first try and then record the formulas. They are very, very important. Try to know all the formulas and then know that, okay, if I see this question, this is the formula that I need to use to solve this particular question. I wish you all the best, and then see you in the next video, which we are going to talk about differential equations.